So if you live in the United States, you're probably aware of the presidential race between Donald Trump and Hillary Clinton. So here we have two hypotheses. So analyst A says that, hey, Trump and Clinton are tied for the American people's support. And then there's analyst B who rejects that claim and says that actually no, Trump has a majority of the American people's support. So we're going to go with analyst B's claim and see if he's right using a stats test. So the problem that we face is that we want to figure out something that talks about or describes an entire population. And those are what are called parameters. And it could be like a population mean, population proportion, population standard deviation, but it's often hard to figure out a number that you can only figure out if you truly figure out if you take every single person, like every person in America. But what we can do is take a sample or a smaller portion of that population. We can find a statistic. So in our case, we want to find a sample proportion that describes or does a good job in describing a population proportion. Now to run the actual test, we need to have data. So here's a sample of 50 Americans, alright? So this is kind of made up, but it gets the job done. So let's say 31 say that they support Trump and 19 do not. So clearly, Trump seems to have a majority of the support, at least in this sample right here. Now, let's just confirm that we have some conditions that are met. So make sure that the sample that we have picked here, the 50 Americans, is just as likely to have been taken as any other set of 50 Americans. That's called a simple random sample. So we assume that this is actually a simple random sample. Now, there must only be two outcomes. In this case, there's some people who support Trump and some people who do not. So perfect. And now we have to make sure that when we multiply our sample size by the assumed proportion, that number is at least 10. And our assumed proportion is 0.5 because we assume that Trump, we're going to focus on Trump for the sake of simplicity. So we'll say that the support for Trump is assumed to be 0.5, or that there's no majority support. Trump and Clinton are tied, right? So that number has to be at least 10, and that's perfect because that works out 50 times 0.5 is greater than 10. And our sample size is less than 10% of the population size, because 50 is certainly less than 10% of America, right? And that America's population is like 350 million. So let's take it from analyst B's perspective. So he wants to say that, hey, Trump actually has a majority of the American people's support, or that P is greater than 50%. But for him to say that, he needs to disprove what analyst A was first saying. Remember, analyst A said that, no, Trump actually just has a 50-50% support with Clinton. So analyst B really needs to disprove the null hypothesis in order to prove the alternative hypothesis. Now what he's going to do next is he's going to take a bell curve, and this represents all the possible samples of 50 Americans that you could possibly take, and we assume that bell curve is centered at our assumed proportion of 0.5 or 50%, and then we look at our sample proportion. Remember, 31 out of the 50 Americans that we sampled ended up supporting Trump. So 31 out of 50, 62%. So that's where this number comes from. And now we're going to work with a bell curve that actually is centered at 0. Or this bell curve, we're going to standardize this bell curve. So when we do that, we're going to end up with actually a really cool curve that is centered at 0, which is always a nice number to work with. And the number that corresponds with our sample proportion is actually how many standard deviations away from our center is our sample proportion. So if you do a z-score, you find that our sample proportion is 1.69705 standard deviations away from the center. So next, what we're going to do is we're going to take the area under the curve from our sample proportion beyond, so to the right. This is the kind of the magic part. So we want to find if the area under the curve, you could even use calculus, or you could just use your calculator, which can usually do this for you. So this area under the curve, it represents the chance that your sample proportion is greater than 0.5 just by chance alone. That we just got lucky that our sample proportion was greater than 0.5 or 50%. That just happened by chance alone. So to figure that out, to figure out if our answer is actually, our p-value is significant or not, we need to compare it to our level of significance. So to figure out what our level of significance actually is, we need to first understand, as analyst B, how confident do we want to be in whatever conclusion we make. Let's say we want to be 95% confident in our eventual conclusion. So our level of significance is actually just 1 minus that confidence level. So 1 minus 95% is 5%. So we want to compare our p-value to our level of significance, and this is a nice handy thing to remember. So if p is low, HO must go, right? So since p is lower than our level of significance, that means great, our results probably didn't just happen by chance alone, and that we can actually reject the null hypothesis. And so finally, now that we've rejected the null hypothesis, remember that means we can conclude that the alternative hypothesis is true. So analyst B can say that we are confident to the 5% level that yes, Trump has a majority of the American people's support for presidency. So hopefully that video was helpful, and I will see you next time.